Hello, everyone. My name is Aaron O'Neill. I'm from the Silverlight team, and welcome to the 3D graphics session. You guys ready to see some 3D? Come on, guys. This is awesome stuff. All right. So let me switch over here. I've got a 3D demo for you I'd like to start with. That's not it, but that is Bing. All right, guys, so we're going to take a little tour of the feature. I'm going to show you through the Windows Cafe in Paris. Anyone ever been here? All right, you guys. Awesome. So this was a cafe that was opened for the launch of Windows 7, and I'm just going to walk you through to show a few of the features. So you can see over here we have the Surface table, some great touch-based apps. We can go over here and grab a salad, order a cafe, or té, or however you pronounce that. And back here, you can see we have a nice little sitting lounge. And I love the lights here. You can see the green ambience just shining onto the walls there, the red light there. Some nice effects. And we'll head upstairs here. You can see some more of the cool architecture of this place. And I just love the lighting effects coming down from the ceiling there. Great. You can see some art on the walls here. Use one of these laptops here. Play some Xbox 360. And back here we have this groovy lounge that I tell you what would make Austin Powers proud. So now let me show you this. This really demonstrates, I think, just how cool this feature is and what it can do for you, especially in terms of performance. So look at that. I can zip along that hallway there. Full speed. And if you notice the frame rate counter, 60 frames a second. Thank you. So this model is about 140,000 triangles, and that's orders of magnitude more complex than the types of scenes that we could draw in the past in Silverlight. So this is really the type of feature that has the potential to really create a lot of new types of applications. So with that, I'm going to show you guys how you can do this yourself. So let's get started. So here's what we're going to cover. I'm going to talk through some of the basics of the feature. We're going to talk about the requirements that you'll need to use the feature, take advantage of the feature. I'm going to show you how you can compose 3D into your pages, into your application, and then how to actually draw the 3D graphics themselves. We're going to go through some essentials of 3D. We're going to talk about animation and texturing. And then we're going to cover some advanced topics, just a little medley of things like threading. And then we'll talk about what's in the product today and what's coming out after the beta. Okay, so let's go ahead and talk about why we're doing this feature. So why are we doing 3D graphics? You guys have heard a lot of great stuff about HTML5, and we're doing some fantastic work there in IE, and we're going to continue to do some fantastic work here in Silverlight, and 3D is a great example of that. So from speaking to you guys and looking at our customers on user voice, this is one of the most requested features on that site. And from speaking to you all, we know there's a lot of people really looking forward to this feature. And it's easy to understand why. As I just showed, this feature really allows you to create way faster applications. You can just get orders of magnitude more performance. You can create more immersive, more interactive, and more visually engaging applications than was possible with just 2D alone. And the great thing is, modern devices are 3D ready. So the web is really ready today to take advantage of all of the great 3D innovations and applications that you guys can write. So I'm going to walk through a couple more scenarios and just show you what you can do with 3D. So this is an example of a geographic overlay. And a lot of data today is geographic in nature. So if you're looking at population densities, or in this case, transcontinental airline flights, there's a geographic component to it, and 3D is a great way to visualize that data. Science and astronomy, if you guys saw the keynote this morning, this is the Worldwide Telescope, and obviously the solar system and the astronomy is a great application for 3D, and we're doing some great stuff there with Connect. On the, excuse me, sorry. Okay, 3D charts and reports. This is kind of the classic data visualization. You guys are, I'm sure, familiar with it. But 3D charting and reporting, of course, is another great way to look at your data and really get another perspective than just 2D. And of course, you've seen this medical imaging demo. We do believe that medical imaging is a great application for 3D. And you can see on the right there the different layers of tissue. So a lot of exciting stuff that can happen there. And this demo was shown by John Papa during the keynote. This is a house builder scenario. So you go in, you lay out your floor plan, create your 3D geometry, and it builds up your house for you. And then it spits out the construction list and prices for building the house. So another great scenario for 3D. So what you'll notice is all of these scenarios are focused on data visualization, business. These are kind of our key focuses for this release. You can obviously do other things with 3D, education, training, games, and simulation. But data viz and business scenarios, again, are the key focus for Silverlight 5. So let's talk about the APIs now. So what do these APIs look like? Well, they look like XNA. So if you guys are familiar with XNA, it's a fantastic set of libraries for creating immersive applications, creating 3D applications, and everything that goes along with that. And so we're going to be providing a new drawing surface control, which will allow you to compose 3D content into your pages. And then from that surface, you're going to get all of the core XNA graphics APIs. You'll have access to those so that you can draw using a graphics device. So you're going to have full access to the GPU. We're going to provide shader model 2 effects, so you can create some really nice effects. Some of those you saw in the earlier demo. And here's how we're going to package these. So we're going to be putting in the runtime itself, in the Silverlight 5 runtime, the drawing surface control and XNA graphics, and we're also providing the sound effects from XNA. So you guys may have heard of this referred to as our low latency audio feature or high performance audio. That sound effect, that's going to be in there as well. And then in the SDK, we're going to provide the map library that you might be familiar with from XNA and the built-in effects system. And those will be in the SDK, and then those get bundled with your application so that when you ship your app, that functionality is provided. Okay, so let's talk about what you need to actually run this. You're going to need a Shader Model 2 GPU. This is something that's very common today. Most hardware, most systems today are shipped with a Shader Model 2 or higher compatible GPU. And I want to talk about the experience on Windows here for a minute. So we're going to have two experiences. One is the default. If you're using a driver that is Aero compatible or one of the newer drivers that's available on Vista Plus, the feature is just going to work out of the box. So no user consent required. If you have an older driver, we are going to require that the user provide consent in order for you to access 3D, or you'll need to be running in elevated trust. And so the reason we're doing that is we want to make sure that we can guarantee a secure and compatible experience for everyone. And so by default, we are going to block, as I mentioned, some of those drivers, such as some of the XP drivers. And so your application is going to be able to detect whether or not 3D is available. If it's not available, then the application will be able to provide an experience that allows the user to decide whether or not they want to opt into the feature. And the way that opt-in works is you can right-click your app, go to Configure, and you'll see this permissions dialog. Some of you may have seen this before because it is in the product today. And you'll see the domain of the application, where the application came from. and the request to use insecure drivers here. So the user can click Allow, and from then on, that application will have full access to the GPU. Okay, so let's talk about how Silverlight 3D, or XNA, relates to some other Microsoft technologies. You guys may be familiar with WPF 3D, and we chose, of course, to bring in XNA as opposed to WPF 3D, and I'll talk about some of those reasons why. So WPF uses what's called a retained rendering model, and this model is very declarative in nature. You can put your 3D model declarations right inside of the XAML for the page. And this worked out great for a lot of scenarios, but some scenarios do require a little more direct control. And a lot of applications want the flexibility to write directly to the graphics card without an intermediate layer. And for those scenarios, we're providing the XNA graphics stack. And this stack uses a direct rendering model, also sometimes referred to as an immediate mode rendering model. And what this does is it gives you direct access to the GPU. So you have full flexibility, full control over all of the states, all of the buffers being sent to the GPU. So you have maximum performance, maximum flexibility in terms of the types of apps you can create. And this web version of XNA graphics is very complete. It includes the core graphics functionality. Direct 3D, many of you may be familiar with that already. And XNA is very similar in nature to Direct 3D. A lot of very similar concepts. So if you're familiar with Direct 3D, you should have a very easy time getting started with XNA. We do provide, of course, some additional developer efficiencies using XNA, as we do all of our managed APIs, which helps you get up and running even more quickly. So let's talk about some of the other industry technologies. You may have seen, they all follow a similar model. We're all moving towards an immediate mode API. And the reason for this is what I just mentioned regarding the scenarios. If you want direct access to the GPU, this is the type of API you're going to need. So it's, again, very similar. However, ours is built on XNA. XNA has been around for 4 releases now. It's available on Windows Phone, desktop, Xbox, and now for the web. So you have a wealth of information to draw from already. Many of you may already know how to use this feature. So it is very easy to learn. And the great thing is, now you can use all of the power of the Silverlight UI system and combine it with the immersiveness of XNA and 3D in one application. This is something we've heard from a lot of you guys, and we're happy that now we're able to bring those two together. Thank you. So the features I'm talking about today are the features that are in the beta. We have the Windows features available for you all to try today. And we're going to be making some additional changes to the assemblies and adding some additional features after the beta. And I'll talk about what those are once we get through some more of the content here. Okay, so those were the basics of the feature. What I'd like to do now is walk you through actually creating an application and walk through what you need to do to leverage 3D in your apps. So the first thing you need to do is give us access to the GPU. So this setting exists in Silverlight today, and what you do is you go into your HTML page to where your control is, and you add this enable GPU acceleration parameter and set it to true, and this gives us access to the GPU. If you don't do this, you're going to get an empty scene, and you will lose a lot of time. So please remember to set this. So the next thing you're going to do is add the drawing surface. This is the new control that we're adding. Just put this in your page where you want it to go. It works like any other control. So it participates in layout. You can resize it. And what you'll notice here is that there is a draw event. So let me talk about Canvas for a minute. Many of you may be familiar with Canvas. And with Canvas, you put your elements like your circles, your lines, all of the shapes that you want to draw, you can put those in your XAML inside of the Canvas element. With the drawing surface, you're going to write that in code as opposed to XAML. And so this draw is an event, it's a callback that we're going to give you so that you can tell us what you want to put on this drawing surface. And this is what that looks like. So we're providing draw event args here, and this is going to have an XNA graphics device right on it. So with this device, you can see in this very simple example, we're clearing it to get kind of a blank slate, and then you can draw some primitives like some triangles. And what I'd like to talk about here next is this invalidate surface. So we want you to have control over how fast you can render. We don't want to introduce any artificial limitations, and we also don't want to assume that you want us to draw every frame, because you may want to not draw every frame, in fact, if you're trying to control battery life or power consumption. And so invalidate surface tells us that you would like to have another callback the very next frame. So if you want to draw every single frame, if you want to draw 60 frames a second like you saw in that demo, just add invalidate surface to your draw callback, and we're going to call you, keep calling you every time, so you can provide us new content. Okay, so that's how you put the control into your page. Once it's in your page, you actually need to draw some 3D. All right, so this next section here, we're going to talk about how you draw 3D to that surface. So a 3D model is just a mesh of triangles. And these triangles can be shaded with color or an image, and then you can illuminate them. So you can see, like in the dolphin example there, that there is some shading applied to those triangles. So what we're going to do is build a very simple application just to draw a single triangle. So let me show you what we're aiming for here. Okay, so this is our first triangle. This is what we're going to walk through the process of drawing and getting onto the screen. Okay. Okay, so that triangle has 3 points. And what we're going to do is specify to the graphics card, let it know that we want to draw a triangle, so we're going to send those 3 points to the graphics card. Those points are what you call a vertex. And vertex has an X, a Y, and a Z position in space, and that's how you position these points relative to each other. And you can connect these to form a primitive like a triangle. And you can then take these triangles and put them together to form your mesh. So you can see a couple examples here. There's a triangle list or a triangle strip. That's how you create a mesh. Nice thing about a strip is that you can see some of those triangles can share vertices if they're next to each other. So it's a little more space efficient. It's often used to keep space down. So something to keep in mind, I mentioned there's an X, a Y, and a Z. You'll want to make sure you know which way those axes point. So X, of course, is the horizontal, Y is the vertical, and Z in this case points out from the viewer or out towards the viewer. So this is what's called a right-handed coordinate system. This is the same thing that XNA uses on the other platforms today. Okay, so this graphic here, don't let it intimidate you. This is the full pipeline that we're going to walk through. And you can see, if you just look at the top, that we have our geometry on the left, and this geometry is simply a collection of points. And those points get fed into what's called a vertex shader. A vertex shader is a program that runs on the GPU. And it typically applies transformation and lighting to the geometry that you sent to it. And then once that's done, that geometry continues to get processed and gets fed into a pixel shader. And this is where we actually rasterize the geometry and convert it into pixels that you see on the screen. Pixel shader gives you another opportunity to modify what those pixels look like. So now we're going to walk through the rest of these steps in a little more detail, and I'm going to show you the APIs that you're going to use at each step of this process. So I mentioned that you use a vertex to specify your points. In this case, we have the 3 points. And you can see that in addition to position, you can also specify a color. In this case, we have red, green, and blue. And we have also the potential to add texture coordinates, which I'll speak to in just a minute here. So we want to send these 3 points to our graphics card. And the way we do that is we put those points into what's called a vertex buffer. And this is a buffer that's created on the graphics card. And one of the first things we need to do is tell the API what our vertex looks like. Because as I just mentioned, those formats are flexible. You can have a position, a color, a texture coordinate. And so you need to tell the API exactly what the format of your vertex is. So this is a simple one. It only has position and color. Vector 3 for position. You can see X, Y, and Z. Color are red, green, blue, and alpha for transparency. And that is the structure that we are going to use to initialize this list of points. Now, the other thing that's happening here is there's a vertex declaration. And this declaration is a little bit of extra information that we need to know that even though you've defined the structure, we need to know exactly how those structure members are used. And so there's a position and a color indicator here. You can see when we define these vertex elements, I'm saying that yes, that first element at position 0, which is this guy here, is a vector 3, and it's used as a position. So that's all we're doing. We're just letting the API know what those fields are for. So here's an example of how you actually finish populating the vertex buffer for the triangle. So we have the list of vertices that we're creating at the top here. So we're creating 3 points for our triangle. We're setting the position of those points. We're setting the color of those points. And then the next thing we do is create the actual buffer on the card. So this vertex buffer uses the declaration that was on the previous slide. And we pass in the vertice count. So we're telling it, create a buffer with 3 vertices in it, and set the data from the list that we previously created. So what that does is it copies from the CPU the list of our points that we initialized in our array here to the GPU. So at the end of this function, you have a fully populated vertex buffer, and you have defined the geometry that is going to be drawn. So the next thing that happens is that geometry gets passed into a vertex shader. And this shader, as I mentioned, applies additional transformation lighting. Now, shaders are typically executing on the GPU, which is great because you get phenomenal performance that way. Our shaders are written in HLSL, and it's a fantastic high-level language, very similar to C. And so you have a lot of great functionality there from that language. You can compile that using the FX compiler in the DirectX SDK. Or if you have a shader compiler already that you're used to or accustomed to using, you're free to use that as well. So I'm going to show you what a vertex shader looks like in a minute, but right now I'd like to just give you a little more context on some 3D concepts. So when we defined the triangle a couple slides ago, and we put those points there, we were defining those points in what's called model space. So those points were relative to each other to some origin, such as at 0, 0, 0. And if you want to have more than one object in your scene, you need more coordinates than that. So in this case, there's another space of coordinates called world space. And you can imagine being able to position 2 objects relative to each other, like an apple and an orange. That would be done using world space. And you define these transforms using a matrix. So we provide the XNA math libraries, and you'll be able to use those matrices, those types, in order to represent your positions in the scene. So once you've positioned your objects in the scene, usually you're going to observe that scene from the perspective of the viewer or a camera. And that is called camera space. And so there's typically another matrix that represents the position of your camera and where your camera is looking. Finally, we're going to be projecting the 3D scene onto a 2D monitor. And that is done using a projection matrix, also referred to as projection space. So these are the different transformations that typically happen inside of a vertex shader. Now, you can also do these on the CPU and pass those into the vertex shader. And then the vertex shader will be able to use that information to move your geometry through the 3D scene. So let's take a look at a vertex shader. Okay, so what we have here is a very simple vertex shader. So you can see right here we have the world view projection matrix. This is on the GPU. We're going to be passing that into the shader from the application. And you can see here this vertex data. This is a mirror of the structure that we had on the CPU side. We're also letting the GPU know that we're going to be passing this into it. And then this is the output structure, which is essentially the same thing. We're going to output a position and a color. So here's our main shader function. Very simple. All it does is take the position from the vertex, so one of those points of our triangle, and it multiplies that times the matrix that came in. That's the transformation part. And so that actually moves the point into the space that can be drawn. And then we're going to pass the color value through unmodified. So no changes here. We specified red, green, and blue. That's what we want to see. Okay. So after that vertex shader runs, we do some additional processing. We clip out anything that's not going to be visible, because we don't want to draw it and pay the performance cost if it's not viewable. We cull surfaces, meaning we take those away as well if they're not facing the viewer. So this also helps us to increase performance. And then finally, we convert that geometry into pixels. And that's when your pixel shader runs. So the pixel shader, as I mentioned, takes in the output from the vertex shader, and also is able to sample additional color or texture data and output the final color value. And what I'll show you now is what a simple pixel shader looks like. Okay, so all this pixel shader does is it takes the color and returns it. It says that this is the color from the vertex, and this is what we want to use. This is what we want to draw. And this is interpolated across every pixel. So let's see. After that pixel shader runs, we do some additional tests to make sure that that pixel is visible according to alpha, depth, or stencil rules. And once we do that, let me show you my app here. So this is the exact same code that you saw before. And there you go. That's the triangle that you get once you go through the entire pipeline. Okay, so the pipeline that I previously showed is sort of the resource initialization that you need to do up front. So you create those resources, you create those shaders, and then in your draw call, this is what we call every frame. This is where you set up your pipeline, and this is where you actually draw the triangle. So the first thing you do, in this case, is we're clearing the surface so that we have a blank canvas to work with. And then, we take the vertex buffer that you created previously, you set that on the graphics device, you set the shader on the device, and then you pass in, I mentioned before, that matrix. We pass that into the shader so that it has that information to work with, set up the pixel shader, and then finally we draw the triangle. So this is executed every frame. And you have, again, full control, as you can see, over the pipeline and over all of the states going to the graphics card. So this is what's going to give you your maximum flexibility and maximum performance. Okay, so a couple things to keep in mind. When you're drawing every frame, you want to make sure that everything that's in that draw callback is kept very fast and very tight. You don't want any extra logic going on in there because that's called every single frame. And so avoid creating any resources. You're going to want to do those up front. So textures, vertex buffers, those things that I just showed you. All of those you're going to create up front and not in your callback, right? In your callback, you want to focus on drawing. And so you also want to avoid allocating any new objects inside of that callback. Again, it's executed every frame. If you keep allocating objects, you're going to drive the garbage collector crazy. So don't do that. Okay, and if you have objects that are very similar in nature, you can batch these up and draw them sequentially. Try to minimize the state changes between things that you're drawing. That will give you a little more performance. Excuse me. Okay, so those were the high-level view. That was the high-level view of how you actually draw to the surface. And as you can see, there's a lot to it. There is again, you have full control over the pipeline, so you really have to, configure that for your application. So let's talk about animation. So we're going to do another demo here, and just like the triangle, this time we're going to create a cube. It has a few more triangles in it. Now, this doesn't really look like a cube, does it? Looks a little more like a square. So you can imagine if we were able to actually rotate this, we might be able to see that this is a cube and not just a square. So that's what we're going to do. So a little context on animation. Animation is really changing the transform of an object over time. So when I say transform, I mean the three classics: translation, rotation, and scale. And you can see a little sample formula at the bottom here, how we're applying that. These are the properties that you're going to modify over some time period. And that's how you're going to get motion in your scene. And something to keep in mind is that frame rate by nature is inconsistent. So you want to use time-based animations instead. And the way to think about this is if you set up an animation and you have an object that's going to be moving 5 meters, and if you move that object 5 meters every frame, if you get 30 frames, you're going to move half as far as if you get 60 frames. So you want to decouple your animation from that. And the way you do that is to create a time-based animation and use what's called the delta time between 2 frames. You can see at the bottom there, if you start at some origin and you move in a direction at a speed, you can just multiply your delta time there, and that will decouple you from frame rate. So these are such commonly used properties that we've made them available to you. They're available on the arguments that we're passing to you in the callback. So you have access to the total time, to the delta time. These are great properties to use when you're animating. Okay, so let's add some rotation to that cube. This is the draw call of the cube. It looks very much like the draw call from our triangle. And the difference is we're adding a rotation matrix here. And you can see what we're doing is multiplying times a total time value. And this is a time value that just continually increases, and so we get a continuous rotation every single frame that this is called. It's going to advance a little bit further. And so let me show you that. So there you go. We actually do have a cube, and it's not just a square. Thank you. Okay. Let's talk about texturing. So textures are a great way to add some additional definition to your scene. The cube that you just saw had basic colors, red, green, blue, but you might want to actually apply an image to your geometry. And the way you do that is with a texture. So you can use a texture for color data, which is like an image like you're seeing here with XNA and Silverlight. You can also use textures for other types of data, like height information, in this case, something called a normal or a bump map. You can use it for lighting, additional elements in your scene to add some additional lighting to your geometry. And so all of these things you can do with textures. They're all in the product. And let's talk a bit about how you would write a pixel shader that samples from a texture. I mentioned before that the pixel shader is what determines what color is output to the screen. So your pixel shader is where you're going to read your texture. And you do that using what's called a texture sampler. This is also available. And that texture sampler is going to read the values from that texture. And it's going to know what value to output based on the coordinate that you pass into it. So if you remember, we had previously defined a vertex that had a position and it had a color. Instead of a color, you can also add a texture coordinate. And that texture coordinate will allow you to specify how you want to wrap this texture on top of your geometry. And so let me show you what that looks like. Okay. So if you notice this new structure here, now we have a vertex position texture instead of a color. And this is taking in a UV texture coordinate, which I previously mentioned. That texture coordinate is how you're going to index into your image. And the pixel shader is what does that. So this is a pixel shader that samples from a texture. And you can see at the top here, we've defined our sampler. This is what's going to actually read the texture. And here's our main function that samples from the texture using the coordinates that were passed in from the application. And so again, the application then is defining how we're going to wrap that texture onto our surface. So in this case, what we're doing is we're going to wrap the XNA and the Silverlight image that you see here, we're going to put that on top of the cube. And so that pixel shader is what actually helps to do that. So we're going to zip down here, and you can see we're defining the faces of the cube. We're passing in the coordinates. We're passing in the texture coordinates. And when we draw, it's pretty much identical. The main difference is I'm actually setting a texture here on the graphics device. And this is how you actually inform the device that you want to draw using an image instead of just a color like what you saw previously. So let's go ahead and run this. And you'll see what our cube looks like now. So now we actually have Silverlight and XNA together on our 3D cube. Okay, something to keep in mind is that Silverlight today already has an image API. And you can still continue to use that image API. But what you're going to want to do is load images into a texture so that you can put it on top of your geometry. And the way you do that is to create your image like you would with Silverlight today. And then you can initialize a new texture using the dimensions of the image. Once you've done that, you can copy the data from the image from Silverlight over to your texture. And that's going to load it into the GPU. So this copy to method, this is a new method that we've added to bitmap source to allow you to load any of your image data into an XNA texture. So that's one of the additional integration points. Something to keep in mind is that Silverlight today uses a pixel format of blue, green, red, and then alpha. This is the order that we put the color data in. And XNA uses red, green, blue, and alpha. And if you're exchanging images between the two, you're going to want to either use the copy to method, which takes care of that for you, or just keep this in mind, and you'll need to swap those color channels yourself. I would recommend using just copy to. So here's another example of what you can do with textures. So this is really cool. You have the image data on the left, which has the color data, and then in the middle, you have some additional information, some height and some additional texture detail there. And when you combine those two, you get the effect on the right. So this is what's called a normal map or a bump map, and it's a great way of getting some additional detail out of your scene without having to add more triangles. So all of this is something that happens in the pixel shader. So this is something that you can easily do to add some, again, some highlights to your geometry, make it look even more realistic. Okay, so that was texturing. Now we're going to go through a few more advanced topics. I want to talk about the fact that we have multiple threads in Silverlight. So we have that for performance reasons. We have a UI or application thread, and this is what most of the code that you guys write probably runs on. You can also, of course, create background threads to do additional work. And we have a composition thread or a render thread. And this thread is what we use to compose the graphics that you're seeing on the screen. And the important thing to note is this callback occurs on that render thread. So that has a few implications. That means that you need to make sure that if you're writing to your data model from the UI thread, and then you're reading from it in the callback or in the composition thread, you need to make sure that that is done in a thread-safe way. And I'll talk about that in just a minute. And then you're also going to have two different devices that you're going to be working with. Because typically you're going to create your resources or initialize your resources. You're going to do that on a different thread than the composition thread because you don't want to block rendering for the user, right? So here's what I'm talking about. So in the draw callback, there is a graphics device, and that's the device you should use when you want to draw. That device is the one for drawing. If you want to create your resources, such as a vertex buffer or a texture, we're going to provide a new graphics device that's sitting off of the graphics device manager. And this is a global device, and you can use this from the UI thread or from another thread to actually load up the graphics card with the resources that you want to draw. So in terms of your data model, as I mentioned before, you can update your data model from the UI thread or a background thread, depending on whether it's driven by user input or if you're driving your scene using, based on physics. That will typically be a different thread that's updating your model. And then in your draw callback, you'll read that data back. So if you're manipulating something with the mouse, that will happen typically from the UI thread, and then you'll read those values back in your callback. If you're trying to draw several things and you want to make sure that they all move at the same time, maybe you want to make sure that 3 things happen before you draw the frame, you might need to use a lock just to make sure that all of the updates occur atomically instead of one by one. So this is an important point. Don't access a dependency object from the callback. You can, but we will throw. Dependency objects are bound to the thread that created them. In Silverlight's case, they're always bound to the UI thread. And so if you try to access a dependency object from the composition thread, from the render thread, you're going to get an exception. And so what you can do is you can read, if that dependency object or a dependency property, for example, is backed by some field, you can read that field directly. Just don't try to access the property. Something else to keep in mind is that Silverlight has a storyboard animation system. It's a great system for deterministic animations. You can use it to navigate and create an animation, something that flies through a scene, for example. But something to keep in mind, again, is storyboards animate dependency properties. And so, as I just mentioned, when you're reading back that data, you'll need to make sure that it's done in a thread-safe way. So typically, you'll read back from a field that is backing that property. Now, I showed you animations before, and 3D is commonly dynamic, right? It's often driven by physics or some other driver. And so those animations are, again, done by transforms, done by matrices. These are the types of structures you'll be working with as opposed to maybe some of the property-based things that, that you've worked with in the past with Canvas. Okay, I mentioned before that the developer has a way to detect whether or not 3D is available on the particular system that we're running on. And this is the way you're going to do that. This global graphics device manager is what has a render mode and a render mode reason. So this will tell you if you have hardware or not, and if not, it will tell you why you don't. So if you're having trouble getting 3D up and running, check out these properties. This is a great way to debug and troubleshoot your app. Okay, so we've had a lot of requests for blending support, adding additional blending support in Silverlight. And the great thing with XNA is that you really have full control over the type of composition that you do in your 3D scene. And so we now have full color support and full blending support in the product when you're working inside of the drawing surface. And so something to keep in mind, you know, there's another formula up here, but I'm not going to go into great detail on this, just other than to let you know that you guys control how that blending works. We do use what's called pre-multiplied alpha, and that's just something to keep in mind. Pre-multiplied alpha, basically, if you're familiar with the alpha channel or transparency, we multiply that and add it to the color values for each pixel, and that helps us save some time when we're doing composition. Long story short, if your blending looks a little funky, just keep in mind that the surfaces are pre-multiplied as opposed to traditional red, green, blue alpha channels that aren't. So if you do need to pass in a color value, for example, that is not pre-multiplied, or a typical color value, use that from non-pre-multiplied method there. And the other thing I'll mention is that XNA has a color type, Silverlight has a color type. So when you're working with those two color classes, just keep that in mind that you may need to do some conversions there. So we're also going to be providing the built-in effects from XNA. And these are really great because not everybody wants to write a vertex and a pixel shader. Some people really, really do want to write them, but some people really, really don't want to write them. And so the built-in effects are great because they allow you to get up and running quickly without actually writing your own shader. And we're going to be putting these into the product after the beta. Okay, so that was our medley of advanced topics. Let me tell you about this. So if you're familiar with XNA, there are some aspects of XNA you're not going to see. Some of those things include the content pipeline, the model system. We're also not implementing WPF here, right? As I mentioned before, this is XNA. If you're looking for something a little more like WPF, if you want that declarative, you know, define my model, I encourage you to check out some of our community content. The Balder 3D engine is an excellent engine for doing that type of declarative XAML-based work, if that's what you're looking for. And we've also heard that a lot of people want to do 2D-based applications in a very performant way. And XNA offers a sprite batch or a sprite class for doing those types of applications. And there is a great project called Silversprite, which is going to be updated to support some of these new features. The great thing, too, about both of these applications is that they do work across different platforms, and they also work across different hardware and software configurations. So Balder, for example, will work even without a GPU, as I've just explained here. So still ahead in Silverlight 5, we're going to be adding anti-aliasing support. And if you notice in some of the earlier demos, there might have been a few jaggies. This will help smooth out those scenes. So that's still on the way. Render target textures. So render targets are great because instead of just drawing to the drawing surface, you can actually draw to an off-screen texture. And this off-screen texture then can be used to create different effects like glows or mirrors. And so that's a great feature to look forward to. Right now, if the device becomes unavailable for some reason, and if you're familiar with Direct3D, you may be familiar with device loss scenarios. Right now, 3D is not going to come back. Sorry. It is a beta. We're going to be adding some additional support to automatically restore the device after the beta. You're going to have some additional surface options. So if you're familiar with depth or stencil buffers, you're going to be able to control those things. And of course, I mentioned we're providing the built-in effects. Okay, so we talked about the key requirements for the feature. You need a shader Model 2 GPU. We talked about how you can integrate the drawing surface into your page, how you can draw to that surface using vertex and pixel shaders, how you can animate that, and how you can take advantage of the total time and delta time properties, how you can do texturing using a texture sampler. We covered some advanced topics like threading and pre-multiplied, or pre-multiplied alpha. And finally, we talked about some of the features that are in the product today and what's on the way. So, if you guys keep working on your 3D rotating cube, you can create a 3D rotating planet and do some fun stuff with it. All right, guys, so I look forward to seeing your applications. Thank you, everybody. Appreciate it. Can I answer any questions? Yes, sir. So the question was, can you overlay 2D XAML on top of 3D output? And the answer is yes, absolutely. Can you read back the output of a 3D render into a Silverlight image? So today, no. We don't provide any readback capabilities from any of the surfaces.
Can you import from existing 3D programs like 3D Max and all those?
So the question was, can you import from an existing 3D program like 3D Studio Max? That's a great question. So we are going to be providing some samples for how to do that. As I mentioned, we don't have the full XNA content pipeline in the product today. And so you will need to use a library or some of the sample code in order to import from a model.
Mac support, are you going to offer that?
Are we offering Mac support?
Yeah.
So, you know, we have Windows, obviously we have XNA across multiple Windows devices, so that's really what we're prepared to talk about today. But,
okay.
You know, of course we're looking into Mac. We understand it's very important to a lot of our customers.
Since Silverlight uses DirectX, does that mean the 3D will be limited to Windows platform?
Since Silverlight uses DirectX, does that mean 3D will be limited to the Windows platform? So I kind of just spoke to it with the previous question. I assume you're referring to Mac, right? So, you know, again, Windows allowed us to get the XNA product, you know, and get it ported to the web to the point that you see it today. And obviously, you know, again, we understand that Mac support is very important to many of you guys. And so we are actively looking into what that story could look like.
Thanks.
Any other questions? Okay. Well, thank you very much, everyone.